So we are welcome back. This binomial expansion problem we are given, and it says that if three successive terms in the expansion of 1 plus x, all in bracket raised to the power of n, are 864, 8064, 13440, 15360, find the value of n and x. So let's see how to go about solving this problem. Now I need to create a foundation for if you are given a plus b to the power of n, it follows this pattern. I've added small terms, that is n combination r minus 2, so we get to r minus 1, and then we get to our r. So this will be the successive terms. This is the term. We are not given whether this problem, whether is the first term, second term, or third term, but we are given three successive terms. So we are going to assume that the first part of the successive term is this, the second one is this, and then the third one is this. So I'm going to write that one out now. So we are going to, let's assume that the first one is this. We don't know whether it's the first term, so I'm going to just jump. Let's just imagine that we have such term plus the first term we are given is 8064. So I'm going to assume 8064 plus 13440 plus the last one 15360 plus 15360. So these are the successive terms that we are given, that this binomial expansion fulfills. So that means that we can copy this. I'm going to copy this out. So is equals to 8064. The next one drag it is equals to 13440. Then the last man is this one. The last man is this 15360. So these are the terms of this. So we try and find what this one will give us. So this one will give us 1, 2. I've already done the simplification. It gives us 128 times 63 times 63. Let's try it in the calculator. I'm right. 128 times 63, 8064. So that is right. So this one that we have here, 2 raised to the power of 7 times 3 squared. Okay, let's leave it like that, times 63. So the next one that we have is still 128 times 105. So let's do that. Let's see what it will give us. 128 times 105. Okay, that's also correct. So what this implies is 2 raised to the power of 7 times 105. Let's leave it like that. Then the last one, which is still also 128 times, so what we have there is 120 times 120. So let's see, 120 times 128. So that's just correct. So what this one implies is 2 raised to the power of 7. Then 120 is okay, let's just leave it as 120. Don't worry, you'll see what I'm going to do. You'll see the reason why I'm leaving it as 1. Now, we know that from this expansion, okay, let me arrange it like this so that you see what is happening. 63 times 2 raised to the power of 7. The next one, 105 times 2 raised to the power of 7 is equals to 120 times 2 raised to the power of 7. So we have this. Now, if you compare this, now just take note of why I'm doing it this way is that 2 raised to the power of 7 is when this man was r raised to the power of 2. So you can deduce that your x. So you see my explanation. Let me just get this straight. Now, this man, which is our x raised to the power of r, you will notice that I have 2 raised to the power of 7, which is the common one. But according to the formula, it's supposed to be r minus 2. This is r minus 1, and this is r. So what I need to do is to find a way of reducing this. I can say this one is 105 times 2 times, okay, 2 raised to the power of 6, and then 2 times 2. So which is the same thing as 210 times 2 raised to the power of 6. That is that. So it has reduced by 1 because we have r here, which is our 7, and then this man has reduced by 1. So now this man also, I can say that one must reduce by 2. I can say 63 times 2 raised to the power of 5 times 2 raised to the power of 2. So that's 4. So 4 times 63, 63 times 4. So this 252. So 252 times 2 raised to the power of 5. So now, if you look at this tells us that our r is 7 and our x is 2. So try and get this. So we have this. This is the simplest way I can explain. So our r, so I'm going to put this. So let's imagine that our r is equals to, so we have 1 plus 2 raised to the power of n. We don't know our n, but fortunately for us, we are given certain terms. So now we know that from the formula you have your n combination r. So your r is 7. You know your r as 7. Our r is equals to 7. So if you are going to, we need to find the value of our n. So we cannot say, because it's not the last term of the binomial expansion, so it cannot be n combination n. So what we have here, we have n combination 7. So you cannot use trial and error method to find the value for your n. So you can start with a number greater than 7. So we start, let's say when n we are testing now using trial and error method. So let n be equals to 8. So when your n is equals to 8, so we have 8 combination, 8 combination 7. So 8 combination 7 will give us 8. So it cannot be the value that we are looking for. We are using this last term. Don't forget n combination r. We must have 120. So our n minus, so let me put this so that you see what I'm saying. So our x raised to the power of r is 2 raised to the power of 7, complying the identities. So your n, so from this we can say that x raised to the power of r is equal to 2 raised to the power of 7, and then n combination r is equal to 120. So that is what we are trying to look for now. So when your n is equals to 9, so we try that 9 combination 7. Let's see what that will give us. So 9 combination 7, that gives us 36. So I'm going to write 36 here. So it is not, the answer we are looking for is not 36. We are looking for 120. Your n equals to 10. That's another value we are taking. So we have 10 combination 7. So let's try that. I'm going to close this. 10 combination 7. 10 shift combination 7. That gives me 120. So if you compare this, so x raised to the power of r raised to the power of 7, that means our x is equals to 2, our r is equals to 7. X equals to 2, r equals to 7. So we have this. So our n is equals to 10. So the question is, the solution to the question is 1 plus 2 raised to the power of 10. So you can try to do the expansion and put those values inside. Let's imagine that this is what we are given. So try and do the expansion. You know this man, you can put these values into this particular equation, into this. Let me copy this so that you see what I'm talking about. So you can just put these values and you see what you will get. So this is how to go about solving this binomial theorem question. So I hope you, so this is how to go about solving the whole problem, this binomial problem. This is the whole solution you're seeing here. So I hope you, so that you can see it in the full page width. So you can see the whole solution on the screen. So hope you find it interesting. So thank you for watching. So please don't forget to like, to share, and to subscribe to our videos, to share our videos, and to like our videos. Thank you for watching. So we'll be expecting you back in another video. Thank you for watching.